Okay, we've seen a handful of theorems in the last couple examples. Now we're just going to practice them with just 3 examples. So part A, what is the measure of angle ABD? So let's find that angle, ABD, and we go back to B, that is the vertex. So we want to find the measure of this angle. What we're going to take note of is that the vertex is outside the circle. When your vertex is outside the circle, the angle measure is equal to half the difference of the arcs. So let's find the arcs that we are creating. This is a secant tangent, so it's an angle formed by a secant and a tangent. We need the inner arc, which I can see we don't know what that is. We also need the outer arc, DA, but I think we have enough information to find arc CA. So arc CA, we'll just take our 360, subtract out the arcs we know, 139, subtract out 151, and we are getting 70 degrees for arc CA. All right, so because the vertex is outside the circle, the measure of angle B is going to be equal to half of the difference of the arcs. So we're going to find arc DA, that's the outer arc, minus arc CA, the inner arc. And then let's just plug in our information. Measure of angle B, that's what we're trying to find. We don't know that. So that's equal to half of arc DA, is that outer arc, 151, minus CA, which is 70. By the way, when you find the difference of your arcs, we should always get a positive number here. So if you subtract and you get a negative number, you probably are put those in the wrong spot. So just be careful with that little detail. We can keep subtracting. 151 minus 70 is 81. So half of 81 is 40.5 degrees. The measure of angle B is equal to 40.5 degrees. All right, part B, what is the measure of arc LM? So a couple of things to notice here. They're asking us for an arc. So if we use one of our formulas from our theorems, we're going to be solving for an arc, which is always inside the parentheses. So just a heads up where this is heading. And then we want to find the angle that's associated with arc LM. So if we look at our picture, we can see here's arc LM. That's an intercepted arc. If we follow it to where the angle is, that's coming from angle J. So angle J, the vertex is outside the circle. When the vertex is outside, the angle measure is equal to half the difference of the arcs. So the other arc that's intercepted from this angle is arc KN. So the measure of angle J is equal to half the difference of the arcs. It's always the outer arc, which is that arc LM, minus the inner arc KN. Okay, so in this example, we actually know the measure of angle J. They told us it was a 34-degree angle right here. So we're going to plug in 34 degrees for angle J equals 1/2 times. Now arc LM is 6x plus 6. So I'm actually going to change that parenthesis I just drew to a bracket, because now I'm going to have arc LM is 6x plus 6 minus arc KN is that 3x minus 5. The reason why I switched to a bracket is just because I knew I would have parentheses on the inside. So we're going to go ahead and clean up in here. We are subtracting a 3x and subtracting a negative 5. So we're just going to combine our like terms. We have 6x minus 3x. 6x minus 3x is 3x. And then we have a 6 minus a negative 5. When you subtract a negative 5, it does turn to addition. So really it's 6 plus 5, which is a positive 11. I'm going to carry it on the 1/2, the equals, and the 34. So that looks a little bit better. Now, if you're trying to solve for anything inside the parentheses here, it's going to be nice to get rid of that 1/2 so that we can kind of unlock our parentheses and start solving that. So to get rid of the 1/2, we're just going to multiply by 2. 2 times 1/2 is 1, so it simplifies away. 2 times 34 is 68, so we have 68 equals 3x plus 11. Now it's just a two-step equation to get x. We will subtract 11 from both sides. That leaves us with 57 is equal to 3x. And then when you divide both sides by 3, we get x equal to 19. All right, so x equals 19. We did a lot of really good work to get this far. Did they ask us to find x? So you always want to go back to the question, and that's when we notice, nope, they didn't want x, they wanted the measure of arc LM. So if we look at our picture, we can see that the measure of arc LM is equal to 6x plus 6. That's this arc right here. So all we have to do is plug in our x value, and we'll have the measure of that arc. So we'll do 6 times 19 plus 6. 6 times 19 is 114. Add 6 to that, and we get 120 degrees. So the measure of arc LM is 120 degrees. All right, one more, part C. What is the measure of arc WZ? So let's find arc WZ in our picture. It's a minor arc, so we go the shortest route to get there. We want to follow the ends of arc WZ to see what angle that's associated with. So if we follow that in, we can see that that is being formed by this 107-degree angle. There's the vertex. All right, so what we're going to take note of is this vertex is inside the circle. When your vertex is inside the circle, the angle measures equal to half of the sum of your arcs. So instead of subtracting, we'll be adding. So we want to know what other arc is associated with this angle so we can see intersecting. So this is what we would actually call a chord angle. It's an angle formed by two chords. If we follow out this direction, that's arc WZ. If we just follow the other direction, we can see it's intercepting arc 74. So that is the other arc that we're going to use. I am going to go ahead and just put maybe a B right there. So we have an angle. So our formula, our theorem, well, I guess we can call it a formula. The measure of angle WBZ, so the angle measures equal to half of the sum of the arcs. So the sum of arc WZ plus arc XY. I like to write out our little formula first so that now we can just go in and plug in the things we know and solve for what we're missing. So we know that angle WBZ, that's this angle right here, is 107 degrees. So 107 equals 1/2 times arc WZ. We don't know that. That's actually what we're being asked to find. So we're just going to leave that as arc WZ plus arc XY is that 74-degree arc. Now we're just going to solve for arc WZ. First step, because we're trying to get inside these parentheses, it is kind of locked in with this 1/2. So we will multiply by 2. 2 times 1/2 is 1, which is why we get to simplify that away. 2 times 107 is 214. And then that WZ, arc WZ plus 74 just carries down. Then we just have one step left. We're just going to subtract 74 from both sides. So we have arc WZ is equal to 214 minus 74 is 140 degrees. So that's a 140-degree arc.